My name is Harrison Leary, and this is my presentation on my Physics 1 Lab 2. So for this lab, what we're going to be doing is dropping an object and comparing the change in velocity as it drops with the models of the various forces acting upon the object. So this involves Newton's second law, which is the momentum principle, which is shown on the right as when F equals dp over dt, or change in momentum over change in time, which is also equal to mass times acceleration. And the forces that are going to be involved here are the gravitational force, which is F grav equals mass times the gravitational constant times negative y hat. And then the drag force, which F drag equals negative b, where b is based on the object. That is another coefficient, and it is multiplied times the velocity squared and the unit vector v hat. So then in this experiment, the toilet paper roll, which is my object, is the system, and the earth is the surroundings. So here we have my video, where, as you can see, as this toilet paper roll is dropped, the change in position over these time steps of 0.033 seconds increases, which shows that the velocity is accelerating, or not the velocity is accelerating, the object is accelerating, which means velocity is increasing. So for my model with just the gravitational force, we have this here. So the arrow pointing down is the gravitational force, and starting at the same height that was used in the experiment, we would end up just under 0.2 meters lower than the object actually fell, which shows that just gravity accelerates faster than the net force acting on the object. And then here we have the model with both gravity and drag force. So here you can see the drag force is acting up and increases as the velocity increases, as it is proportional to the velocity squared. And you can see that it would, in this model, it ends around 0.1 meters above the actual bottom, the floor, and that is shown on the comparison of the models here, where the observed is shown as blue, the just gravity model is shown as orange, and the gravity and drag model is shown in green. And as you can see, the observed and the gravity and drag force models are much more similar in terms of the rate of change of the position, or and the change in velocity, but with just the gravitational force acting, it ends up accelerating much faster because that net force is greater in the negative y hat direction. And then here is my code for the gravity and drag model. So I set the things that were changed. I set the ball dot m, the mass of the object, to 0.05 kilograms. I changed the initial position to 0.942 meters in the positive y hat direction, and I changed b to 0.05 as it relatively accurately reflected the drag force of the object. And then in my code, I set Fg equal to the mass of the ball times g times negative j hat, and the drag force was equal to b, which is that constant, times the magnitude of the ball's velocity squared times positive j hat, and then the net force was equal to the gravitational force and the drag force. Then with the momentum principle formulas, I set ball velocity equal to ball velocity plus F net over ball mass times delta t, and the ball position equal to ball position plus ball velocity dot delta t, which these are just the code forms of the velocity update and position update formulas. And finally, for the arrow scale, I changed the scale to 5 and made the arrow axes in the same directions as their corresponding forces. And now for the conclusion. So what does it mean in terms of whether or not the models predict a terminal velocity? So the model that predicts a terminal velocity would be the one involving gravitational and drag force, as towards the end, when the gravitational and drag forces are equivalent or almost equivalent, there is either zero or almost zero acceleration on the object, which means that the velocity is not changing, which is a terminal velocity. And then if the object had a initial velocity that was thrown downward, it would not affect the terminal velocity. It would just mean that the terminal velocity was reached faster. So it would only change how quickly you would approach that terminal velocity. And that's all. Thank you.